what we as Radisys do, but we're very focused on vertical solutions. This is just one piece of it. So I think between interoperability labs and different kinds of services, some kind of certification, yes. First thing we have to have is some accepted specifications, which we have now. And then, yeah, I think there is a place for that in sort of OCP formality, but it hasn't happened just to make it.
Just like OCP has OCP certification.
That's right. That's right.
Yeah, well, just a comment there is that from an end user perspective, all of these specifications that are suboptimal are to some extent irrelevant. They want to see the end-to-end performance of the system, right? They want to see all of the software elements, all of the hardware elements, providing service with the SLA and quality and robustness and performance that they need. Okay, so it's very, very hard to certify that. Okay, end-to-end performance. So, one example I can use is the military example. The reason that Raytheon and Northrop Grumman and General Dynamics and Boeing exist is because they demonstrate to the government the end-to-end performance of an air traffic control system or a combat management system that the servicemen can use. Right? It's the same in this industry. You need the lab to demonstrate the end-to-end performance, even if you can't demonstrate the scales that they ultimately want to see in deployment. So the specs are important, but I think certification is less important than demonstration, okay, for the end-to-end point of view. So that's just my personal.
But I think, but with that said, I think it is just a law of the as things get bigger, there will be room for, some sort of a proof point. If this works for that, it might only be part of the overall picture, but at least
Some things.
Yeah, exactly. Yeah. So I think that all comes with growth. But short answer is it's not there yet. All right, I think we were going to fly by this because we're not ready for it. We don't have enough time for it. But this was, and this will be out there. This was just like top of my head, the kinds of things that I think are very interesting to discuss. And there are things from kind of a use of open ecosystem hardware and software, and also sort of use of internal resources, external third parties, separate from the products themselves. So questions like, sourcing from a single integrator or piecemeal. ODM what's an ODM, what's not an ODM? But certainly in the supply chain, you have people that are focused on lower level type of thing. They're very well known in these solutions. So we all know who the pieces are. There's a question of who's rolling them up. I think we got to get the dirty stuff on the table right now. Let's talk about margins, right? Everyone's got to make some money for this to work. And what are expectations from different people? Probably different expectations. Who gets paid in what levels? Where OpEx and CapEx are big discussion items. We see things like people have CapEx plans, but they don't have OpEx. And sometimes you do some window dressing to make one look like the other. There's some operational efficiencies, but then we start quoting something and saying, here's the price on day one. Here's how much money you'll save, by paying a couple less people or whatever. So those are some of the things. I think we'll figure out how to tee this up and where that discussion happens. And it'd be good if people can kind of feed in. If we bring people into this. I think that'd be a good one. See it. And this last section will go pretty quick because we have all the time. I'm going to flash up a couple of actual deployments, business examples. I can speak to a couple here. I don't know if you have any others. The first one I'm going to flash, kind of go through. It's something Verizon did. The slide itself, I might have to pull out because I got some logos and stuff in there. It's actually been published. Verizon presented it at a MesosCon presentation because it uses Mesosphere last year. So it's been out there, but it wasn't totally checked off on it. So I'm going to kind of just flash by it here. But there's I just took a couple slides and put them together. There's a link that I can point you guys at it. I just wasn't sure if I can encapsulate it here. But anyway, this was a deployment that we have done, and it's basically it's infrastructure. It's using Cumulus and Mesosphere is kind of the fundamental software infrastructure. It's fairly straightforward. It's running on the DC engine. As you can see some examples there. and is doing basically a storage application, backup application. So that is that's deployed, that's out there, and again, fairly public. Again, I'm not showing you something that Verizon will talk about. They are. They just have to logos and so forth. This is one that I want to just spend a little bit of time on. Some people here are aware of the Cord initiative. That's another forum, that kind of fits in with a couple of others, but basically it's a network infrastructure. Tom knows it very well. Defined for as a software infrastructure for for basically just taking networking applications and designing them in a data center environment. It's fundamentally about disaggregation and SDN control, and along with that comes virtualization domains and microservice architecture. Within Cord, there's a lot of stuff going on, and I can't speak to any deployments, but I can speak to things that are going on and some mapping that we've done to some of the OCP pieces. But again, this is a much longer topic. What is Cord? So I don't have time to go into too much of that. Cord stands for Central Office Re-Architecture. It's a data center. Again, it's infrastructure. You can think of it as NFV infrastructure. I like to think of Cord as the infrastructure of both. And there are liaisons. Cord came out of the Onos environment, so Onos as the controller is kind of an anchor point there. However, with that said, the Cord architecture is about far more than a controller. You don't have to have an Onos controller. And a lot of things that Cord has defined, for example, the fabric infrastructure, how white box switches can be disaggregated, how that SDN control plane manages in a least spine architecture. And that is in place, and again, it's been not exactly deployed, but there have been a certain amount of trials and proof of concepts. There's a couple of flavors of Cord, and they're not the most clever names. It's R Cord, M Cord, E Cord, whatever Cord, and they're just kind of different different areas of focus. So the R Cord stands for residential Cord, M Cord for mobile Cord, E Cord, enterprise Cord. There's some others. The biggest areas of traction. Well, they all have a little bit of traction. There's a lot of focus right now on the R Cord because I think it's based on a technology that is fairly simple to define. So the problem space is not that complicated. It's fixed access, specifically focused on optical access networks on. And so taking the Cord infrastructure and applying it to that. Tom, you might have on one of the calls gave a quick overview. So again, this is all public, so I don't want to get too much into that. So. But there are pieces now. The whole idea is that the whole thing should be open. How much open stuff can you get in there? So the access specific pieces, OLT, getting that open. AT&T is going to contribute some specs that I think Tom will outline later. And there are solutions getting built to those. The hardware that it runs on, you've got servers, you've got switches, you've got storage. OCP is an excellent choice. You can take any flavor of OCP. And the curator open rack that we're talking about this morning is an excellent fit. And just wanted to show us some definitions that we've done that kind of put these things together, concisely. So, so this is just a couple of taking, and I mentioned earlier that smaller size rack is a nice size for this R Cord sort of pod. Where you say, okay, I'm defining within there. Have servers, switches, and actually there's not much storage in this particular thing. And in fact, it ends up being, that's not, there are different configurations. You actually end up, what we see as being more predominant configurations, you have quite a few switch-like elements, right, which would be your OLT elements, again, ideally disaggregated, and less compute. Now, the compute is interesting. It depends on how you deploy this. Cord doesn't dictate where the compute sits, but there's a certain amount of compute functions that you're pulling out of the traditional network elements that you still have to do those. And you can do that right there at the edge in this pod, in your data center infrastructure. Or you can do as little as possible and turn that to something more centralized. And that's an ongoing debate where that happens. But this is an example of something that's been, tire kicked. Some days. That's more on the architecture. I'm going to skip that. Sticking to the Cord here, and I have one more example after this. These are just two sample examples. These have not been deployed as such. But if you want to go bigger, how many can load these racks? I apologize, it's kind of small here, but what you can kind of see there, these are two different variations. You know, kind of sizing to 10,000 subscribers. When I look at how much horsepower is there, maybe a bigger number, but you got to go through the calculations. You know, you can see in the I don't know what this orange kind of color would be a bunch of OLTs that kind of look like a switch. You know, 1U, ideally, you know, with Ethernet elements and 40 and 100 gig uplinks, and then POD links directly terminated there. And then aggregation switches above those. If you have a bunch of those, you need some level. So that's kind of your leaf spine architecture collapsed into here. You've got some of your, you know, connectivity at the top of the rack, and then you've got compute elements in green. And how many of those you need depends on how much you're doing. It could be, the ratio could be very different, but this is one example configuration and power. And then over on the right, there's a bit more. This is sort of thinking GPON, which is a bit of a lower performance, right? GPON is 2.5 gig, so you get some choices there. And then going to XGS PON 10 gig, you're carrying a lot more, so you know you have more compute. And then again, so these are just some example configurations. So these are some of the. This is one of the applications I would say of the technology. Again, these are tight bindings. I mean, there's a lot of different ways to slice it, but this is definitely living in central office. So it's a good example of a central office data center, you know, application. And with your kind of standard data center infrastructure, I do think it's a tremendous advantage to get that ability to put compute beyond just what you need for the service itself. But, you know, Steve was saying, now you've got a space, right? What else do I need to do there? What other kind of compute could I do to offer some additional services? I've got a really good place to do it. It's not special. It's special. This is a different variation of cord, the mobile cord, mapping some things into there again. Unfortunately, I can't talk about any deployments yet because they're not public and they're not done, but there's work going on. And so this is really, I'd say, as much as anything, it's a 5G focus. It doesn't have to be. One of the demos we've done is 4G elements, disaggregated them, show that running on this hardware. 5G is where it's most interesting because you have enough speed there, you have enough applications that actually can come into that domain, and it's new, so you can think about some new infrastructure as opposed to sort of redoing something that you've already done. One of the things we've done then here is to take and kind of offer a you know, a disaggregated mobile core solution, including the radio access portion of it, and then there's actually some specialized hardware there to connect to a remote radio unit. That's the BBU. And then you've got your network elements. Again, a lot of different ways to slice and dice them, but they're running on compute elements. And then you've got your, you know, loosely called orchestration, but your control domain, your service control domain, again, running on compute elements. So that's a bit of an overlay. I'm not sure that's not a real. I think that might be a overlap. So. All right, this one was something we did. It was public, so it's not a deployment, but we set something up with CenturyLink for a trade show, and we put it together fairly quickly at the MEF show last year. And so basically, this was it was done very, very quickly. It was not complicated, but they're focused on orchestration of Blue Planet. Again, they've talked about that. They've also been talking about cord-like things. So it's a similar disaggregated architecture, but it is not using, you know, those building blocks that we just talked about. And so, unfortunately, I don't think I have a picture of this one, so I just wanted to briefly say this is, you know, another example of kind of a demo proof of concept using this technology. And I think we use the 16U rack. I think it's funny that that's the show stuff. You know, it wasn't actually deployed, but I guess it looked nice. So anyway, that was just a couple. We got a lot of stuff going on, so it's pretty exciting. I think there is some momentum here, but I wanted to show a couple things. These kind of fits with what Steve talked about. You know, they're all in that kind of access space. You know, even the first one that Verizon did with the cell phone backup. It's not access-based, but it's certainly, that's closer to the end, it's a client kind of application, as opposed to something deeper into the network. So that probably, and again, that fits with the idea of this technology, this area being sort of central office as a data center. So, anybody, so any questions about any of these? We can talk offline, happy to. Does anyone else have any, I think in this space, with deployment of anything OCP that you think would be interesting to share with the group? I think we have a lot of kind of learning, kicking the tires and listening here, so that's fine. But if anybody did want to share something.
Rehash a couple of things that have already been announced.
Yeah.
Like the OCP Summit, and in March we announced that we deployed an OpenRack V2 platform to AT&T Foundry in Plano, Texas. That was actually announced by one of Facebook's vice presidents during the keynote address. Also back in London, and also at the OCP Summit, we announced some of the contributions that we're going to be making Nokia to OCP in the form of negative 48 volt DC power, which is definitely a requirement of most of our customers. The EMI shielding, and also emphasizing zone 4 earthquake compliant racks. So we've got for OpenRack V2, which we've got a kit that we'll be offering, it's separately, right? That can be.
Yeah, and I actually had a chance to kind of go, and that was on display in Santa Clara, right? At least the manifestation of that, yeah. Cool.
So we do have quite a bit of interest and activity in OCP. World Congress probably, we presented to, I had to conservatively guess, 50 to 60 different telco operators there. The OpenRack V2 platform. We have deployed for proof of concept OCP OpenRack V2 into I think we're in a total of 5 tier 1 operators now.
And that's, is that under the brand name Airframe?
Yes.
Yeah. Next.
I have a question. Please talk. Believe
Yeah. Yeah.
Can you repeat the question, please?
I think the question is who's doing some of these POCs? Besides, yeah. So I unfortunately, for ours, the only one that I mentioned that's public is that one for Verizon. The other ones I can't name the operators. Sorry, I wish I could, because I just, requires permission and things going on, and some of the stuff is work in progress. So not quite public. And we'll see, right? There's choices, we don't know which way to go. So otherwise I'd like to give you a straighter answer. I can't, not in the public forum, just yet. So we're just coming to the end of the segment.
Oh, okay.
Yeah, and we just did a little roundtable, we could talk about some deployments. I did a couple here. Things in progress.
Wow, so we're right back to the but. So at 3:15 we scheduled a break. 3:30 we have Tom from AT&T who's going to talk about open hardware specs. There's a variety of contributions that they've made over the last 2.5 years. Those have evolved into actually equipment that's being deployed. There's also some work going on with Universal CP. He's going to talk about. Tom actually wanted a few extra minutes today, so maybe we do a quick 5-minute break. Let's see, it's 3:17. So let's try to start at 3:25. We'll give Tom a few more extra minutes. So do a quick break and get back to 3:25.